Welcome everyone to this session, and hope you've had already exciting time at Quantum World Congress. It's great to gather here in the MD. So my name is Sauli. I come from a company called Bluefors, and we are working in the world of code. Our business is in cryogenic measurement systems that allows users to measure devices at or near temperatures absolute zero. And I'm going to talk about today a little bit about the company, what we do in the US. We have some teasers coming up as well, and also some use cases and actions where Bluefors systems are being used. So, many of you might know a company called Bluefors already, what we do. If not, hopefully you've at least seen us on our booth over there in the exhibition area when you come up to the escalators. In short, so we have established quite a position in the marketplace in the quantum technologies, where whenever you see a quantum computer, it's shown. It's very often actually a picture of a Bluefors cryostat. And thanks to an article from IBM, we made to the cover of Time magazine some time ago. So we are a global company doing industrial production. So we brought industrial production to cryogenics. And before that, the field was more working on one-off systems and not on a kind of an industrial production scale. We're about 600, or actually almost 700 people nowadays with different backgrounds. And out of those, we have more than 50 people actually working in the R&D. We have also 2 locations in the US. So headquarters are in Helsinki, Finland. 2 locations in the US, and so far, the team has been shipping out more than 1,400 systems thus far. Taking a couple of quick look on our locations here and what we do. So we have established the sales and service office in Brooklyn, New York, where I'm actually based. And the really core functions there is to bring our engineers and scientists close to the customers, helping with installations, commissionings, technical support, and sales, really be able to serve the US market better. We have another location, about 180 people, in Syracuse, New York, through acquiration of a company called Cryomech last year. And together with the Syracuse location, so we have manufacturing, R&D, services and sales functions, and everything in upstate New York, Syracuse. Focusing much on cryocoolers and pulse tubes, helium management systems, and liquid nitrogen plants. Looking at some of the next steps that Bluefors is taking in the US especially, we are strengthening, of course, our services and sales, bringing our technical experts close to the customers, helping in everyday services, maintenances, things like this. We're building capability for fast response service visits, and also we have been working for a year and a half now as a facility expansion in Syracuse, and increasing the facility by more than about 45%. And of course, the demand comes from the industry, and we're expanding the production of cryocoolers and helium and nitrogen systems. But in addition to that, so we're going to have actually an official opening on Monday, next week Monday, for reopening for the facility. And in the fashion that in Quantum World Congress now today and yesterday, companies have been making announcements, we're going to make a teaser about what we're going to do. So in addition to expanding the manufacturing of cryocoolers and so forth, we're going to be bringing dilution refrigerator manufacturing into Syracuse as well. in addition to, of course, supplying more of our customers with spare parts and so forth. But stay tuned for Monday. I'm not allowed to talk more about today because the official event will be next week, and there's going to be press releases and so forth. But exclusively to you guys here. Let's talk about then a few things about where our systems are in use and what kind of development we've done lately. So, do you recognize this system? I see some nodding. So, our long-term partners at IBM are actively pushing the limits of quantum computing and currently have the largest qubit counts in superconductive quantum computers of the industry. And really, to keep pushing the boundaries, they needed a large and reliable system to cool their next-generation large-scale quantum computers. This need led to Bluefors developing the KeyDare cryogenic platform. And ultimately, what you see in this picture, exquisitely beautiful machine, IBM System 2, cooled by Bluefors. As quantum computing matures, we see an increasing need for ever more powerful systems. And at this scale, a much larger experimental space is needed, much more cooling power is needed, and at the same time, you need to have easier access to the instrument and to the experimental space. As another example, so when we talk about the quantum computing, as I mentioned, what you often see is the cooling systems produced by Bluefors. But what about the quantum chips itself? So a greater demand for quantum experiments requires greater production capacity for the qubits as well. Here you can see a 300 millimeter wafer, silicon wafer from Intel packed with hundreds of quantum chips. To guarantee the functionality of these chips, Intel needed a way to test and characterize quantum devices down to the electron level, and they needed to do it in volume. And that was not something that you could have from the market at that time. So some of you might be working in the semiconductor industry, so you know that full wafer probing is a standard way of testing wafers. But the need to cool the most quantum devices down to cryogenic temperatures had previously meant that these typically were tested one by one at a time. So companies like Intel needed a way to characterize quantum devices in volumes to scale their production. And working together with the global company AEM and in collaboration with Intel, we built our cryogenic wafer prober. And this system really opens the door for mass production and continued scaling of silicon-based quantum processor, all of which are requirements for pushing forwards towards fault-tolerant quantum computer. In the world of cold, we aim to make operating the cryogenic measurement systems as simple as possible. So simple that, in fact, anyone in this room can initiate a cool down to absolute zero just by tapping a button on a touchscreen. This picture that you can see is from Niels Bohr's Institute from University of Copenhagen, and they carry out state-of-the-art research in superconductive quantum information devices lab. And we heard more about that yesterday, actually, at the 100 years of quantum celebration as well, when we had the grandson of Niels Bohr visiting. So at the University of Copenhagen, they're really excited to be amongst the first to try out our new gas handling system, Generation 2, the beating heart that controls the cryostat operation. And all across the world, research teams need highly dependable and reliable systems to run their experiments, and they really want to focus on the scientific results and driving the progress forward. And we, of course, want to help them. Similarly, here in the US, we recently installed another gas handling system at NYU. So here you can see on the left, Andre Racheteera, an assistant professor in Department of Physics at NYU, and his lab explores the intersection of quantum information, condensed matter, and quantum optics, with the focus on building synthetic quantum materials from strongly interactive microwave photons using superconducting quantum circuits. We're thrilled to be delivering the LD system powered by the new gas handling system to Andre and support his work, as well as the other cutting-edge research in the US and around the world that we're proud to enable as an enabling technology. Furthermore, we're not talking about at Bluefors only about ultra-low temperature range for our solutions. Our solutions go for a wide range of solutions for your kelvins, down from 80 Kelvin to below 10 millikelvin. For example, photonics, we offer diverse solutions for 4K applications, as photonic detectors commonly utilize our pulse tube cryocoolers under the product brand Cryomec. For remote cooling of vibration-sensitive applications in the temperature range from 20 Kelvin to 100 Kelvin, such as trapped ions where we need to cool lasers and laser housings, we offer our cold helium circulation systems utilizing our reliable Gifford-McMahon cryocoolers. And as like in the picture you can see here, Bruker has been having NMR applications with our systems as well. So, as you've seen, we work with a wide range of customers, and as a key technology partner, we're collaborating with and delivering systems to our users and customers that help bring the quantum future closer day by day. I have a few minutes left, so I can tell you a few things about our scalability and supply chain developments as well in the cryogenics. And it's not about just the product development and bringing those high performance, high quality systems to the users where they need in their applications and move the scientific research forward. Our customers have strong needs to meet the environmental, social, and governance conditions as well, as do we. And we're really committed to delivering and commissioning systems with long lifetime and high uptime. And that requires a strong supply chain. We've been taking, for several years now, big steps on improving our own work here. And some of the biggest improvements, of course, are not the most visible. We've been working on ISO certifications. We've been working on putting in place lean processes and methods in the factory and manufacturing. And we've started to increasingly move towards line production, and the Syracuse expansion is an integral part of that. So when it comes to industrialization, there's a lot of work going on behind the scenes, and improving the quality throughout the entire company is a significant portion of that. We know that a small change in part of the process may have a huge impact to the end result, to the end product, the quality of the product, and furthermore to the end user. And our goal is to help you succeed, improve and develop your products and your research. So we're committed to going that extra mile to achieve that. So, to summarize, we've taken our role as the technology enablers very seriously. And we're here to help you grow and to bring that quantum future closer day by day. And with that, I would like to leave you with one question. What challenges can we solve for you? Thank you.